The term blue carbon was coined in the early 2000s to indicate the organic carbon captured by living marine organisms as a counterpart of the carbon captured by the iconic terrestrial forest known as green carbon. The aim was to emphasize the fact that over half of the global carbon sequestration is due to marine and coastal ecosystems. The interest for blue carbon is rooted in its potential to mitigate climate change while achieving co-benefits. Among blue carbon ecosystems, our research focused on salt marshes, widespread on the coastal areas of temperate climates. Situated between land and sea, salt marshes are ecogeomorphic features covered with herbaceous vegetation capable of withstanding the periodic submersion by salt water during high tides. Marsh vegetation absorbs CO2 from the atmosphere through photosynthesis and trap sediments carried by tidal flows. These interactions between biological and physical processes gives to salt marsh surface the ability to grow vertically to keep pace with sea level rise. And in doing so, salt marsh soils accumulate and preserve large quantities of organic matter and thus of carbon that they remove from the atmosphere. Their CO2 sequestration rate can be one order of magnitude higher than that of tropical forests. This may seem counterintuitive and is generally not well known. So our research aimed to highlight these important and often overlooked ecosystem service offered by salt marshes. Quantifying the carbon accumulated in salt marsh soil and their CO2 sequestration potential makes it possible to attribute an economic value to this environment, promoting their conservation and restoration, and thus promoting also the preservation of numerous other ecosystem services that salt marshes offer, such as increased biodiversity, water purification, and coastal protection from erosion and storms. In our recent interdisciplinary study, we attempted to estimate the quantity, the amount of carbon that is accumulated in the soils of the Venice Lagoon salt marshes, measuring the organic matter content in 60 sediment cores. We discovered that organic content in salt marsh soils is highly variable also at a local scale, being influenced by numerous factors, including vegetation and sediment supply, which can vary in time and space as a consequence of changes in the characteristics of surrounding environments. Our data allowed us also to estimate for the first time that the salt marshes of the Venice Lagoon, which occupy currently about 43 square kilometers, can be able to sequester more than 13,000 tons of CO2 per year, which is equivalent to about 20% of the annual emissions from the boat traffic in the city of Venice or the emissions locally produced by the nearby Marco Polo airport. Based on the CO2 price from the European emission trading system, the value of this CO2 sequestration potential can reach nearly 1 million euros. And this value could be even higher if the extent of the salt marshes had not been reduced by 70% over the last century. Our research also allowed us to highlight that the Mo.S.E system, the mobile barrier system built to protect the city of Venice from flooding, could further reduce the CO2 sequestration capacity of salt marshes of the city of Venice by over 30%, limiting the sediment supply during storm surges. So while recognizing the complexity of carbon assessment in such dynamic environments, our research provided important information for the inclusion of blue carbon in carbon balance inventories. And our data also offered important insights in the effects of territorial management strategies on salt marsh conservation and the related ecosystem services, suggesting the importance of an integrated approach. We believe that increasing the interest in the value of salt marshes in the context of climate mitigation may importantly encourage their protection, their conservation and restoration, and this, in the same time, will promote the maintenance of many other environmental benefits.